Hello, and thank you for joining us. I'm Mark Lawson, lithium-ion battery suppression director for toxic suppression. Today, we're going to talk about the Spartanburg-Pruitt protocol for when you can't let an electric vehicle burn out on its own. Spartanburg-Pruitt protocol, we call it because this chief, Matthew Pruitt, former battalion chief of city of Spartanburg, South Carolina, 30 years in the fire service. Upon retirement, took the job as the BMW North American Fire Chief. BMW is the only manufacturing facility in the United States or North America is there in the Greenville, Spartanburg area. And then from his work on the electric vehicle fires has kind of been catapulted to their global or one of their global EV fire leads. Electric vehicle battery fires are challenging. This slide is just summing up the fact that there is no UL, NFPA guidelines, regulations, standards for products, blankets, those sorts of things, and that there is still more validation testing being done by FSRI, UL, NFPA, all the different kind of usual suspects there. Keep an eye out for that information as it continues to roll out. Visual size up, identifying an electric vehicle. Currently in the fire service, there's a lot of different gasoline powered, diesel powered, natural gas powered, electric powered, a lot of different types of things powering vehicles. Knowing what you have in front of you in order to how to fight it is very important. On electric vehicles, the external badging, no front motor, good indication, tailpipes, grills, those sorts of things, and then charging ports, all great indications. Asking the driver is also a great way to try to determine what you're dealing with. And then also understanding that you may run into in the future internal combustion vehicles, a Sprinter van or something like that with a whole charging system in the rear end of it. Types of electric vehicles, there's various different types outside of just the standard battery driven. You have some that are hybrid, which incorporates oil derived fuels. You're likely going to have some in the future with hydrogen on board or maybe or full hydrogen. So there's a lot of different types that kind of charge these batteries and that sort of stuff. It's just kind of letting you know that there's not just one type of electric vehicle. Lithium-ion battery cell types. First, we want to recognize that the cells are generally in between the wheel wells, low in the vehicle. Generally, not a whole lot of rollovers with electric vehicles due to the low center of gravity. The different types used, polymer, prismatic, and cylindrical, different constructions there. The thing we like to point out is the batteries have a safety vent valve. Once you have heat pressurization, that vent releases. We view this as some of the challenges. If you do stop a propagation fire, you have damaged charged batteries. You can imagine that going down the highway on the back of a rollback. One of those or a few of those safety vents release. You have off gassing. You only need around 300 degrees to get that ignition going. Now that car is back on fire on top of a rollback or in a scrapyard or something like that. Battery pack construction. Knowing where the vents are important, especially on extrication. For the most part, the vents are in the rear of the vehicle so that they don't vent into the passenger compartments. However, sometimes you do have those vents up under the A-posts in different models. Understanding the construction, you have the cells we just talked about. They pack those into modules. There could be 7, 8, 9,000 cells depending on the style and the type. There could be 4 to maybe 20 modules depending on the battery system construction. To note, the battery systems do have a vent. That's generally a one-way vent. It makes it challenging to get water inside the battery pack by design. It's designed for gas to flow out. And then also, again, remember that the cells have a vent as well. The places that don't have vents, potentially the garage that you're approaching that may have a burning electric vehicle inside of it or an off-gassing electric vehicle, battery walls and basements or other enclosed areas. So there are areas that could potentially be confined space, explosive hazards. So know that that's a potential threat when you're dealing with batteries. Lithium-ion battery failure. Why did the batteries actually start on fire? Mechanical damage, a piercing, impingement, maybe a car wreck, something like that. An electrical short circuit, an overcharging, maybe something wrong with the battery management system. Thermal overheating internal, maybe there's an issue with the separator anode cathode touch and it goes into thermal runaway. And exposure to high temperatures external, thinking maybe the hot water heater in the garage ignites and now you have the garage on fire, an electric vehicle inside the garage on fire. But essentially you kind of get this circular kind of runaway or thermal runaway, propagation fire, kind of different terminologies there. So the cell goes on the fire, you get one or a few cells on fire. The cells burn for maybe 15 to 45 seconds. They don't generally burn for a long time. However, that one cell then ignites the one next to it and then the one next to it. And that's what the term the propagation is. So that initial fire, that's the thermal runaway on the individual cell. The propagation fire is actually the cell to cell to cell fire that continues throughout that battery pack. It's very interesting, the similarity between the fire going on in the battery pack and then most people's concern, a parking deck, a parking garage fire of a bunch of different vehicles on fire all kind of packed in there together. Greater the charge, greater the reaction. A lot of people aren't aware that the charge state of the battery actually dictates a lot of the volatility of the fire. A large majority of the shipping recommendations are to leave lithium ion batteries at 30% or below for shipping. Generally, you get more off gassing and that sort of stuff, not as much heat, not as much volatility. 50, 75, 80, 100%, a lot more energy release, a lot more fire release, those sorts of things. This got us kind of thinking, why weren't they having a lot of issues doing a crash testing, toxicity, that sort of stuff? And what we found is that NTSB is charging the vehicles to 12.5%, essentially kind of reinforcing that low charge state equals not a whole lot of fire or volatility from the batteries. A great early on scene thing that you can do, especially if you're doing extrication or you have a fire, is asking the driver, do they know what the charge state of the battery was? That gives you a lot of good information of how much battery energy you actually have there and can factor that into your response. Stored energy in lithium ion batteries is a ticking time bomb. Thermal runaway isn't the end of the story. Stopping thermal runaway is not a long-term solution. To truly eliminate the fire risk, you must release the stored energy or the trapped energy within each individual battery. You have to remember that energy is trapped in three layers: the battery pack housing, the battery module housing, and the battery housing itself. And then that thermal abuse kicks in around 212 degrees. So you don't need a whole lot of temperature to start putting pressure on those pressure relief valves and that sort of stuff, creating the potential for reignition. For most firefighters, let's get you kind of thinking, all right, the energy is really the big challenge here. A lot of the challenge is not just the fire. Once we get done with the fire, then we still have this energy challenge, or if we can get to the fire and stop it. So that kind of gets a lot of people thinking about, all right, what could we do? How could we do this? How could we get the energy out of the battery pack? And two things that you need to understand about this is, number one, when there starts to be a thermal issue, the EV is designed to lock the battery energy or the energy into the battery pack. That's in case somebody's trying to get out, in case a responder is responding or pedestrians responding, getting close to the car, they don't get electrocuted. Um, and then also to understand is that the new cars have bidirectional charging. So there could be potentially ways to maybe draw that charge state out of the actual battery there on site. But again, that prevention or that locking of the energy down into the battery pack prevents that capability there on scene at this point in time. Also to note is that generally you can't charge a battery or discharge a battery any quicker than you can charge it. Meaning if it takes 3-4 hours to charge a battery, it takes 2-3-4 hours to discharge the battery, or else you do throw it into thermal runaway. So post-incident discharge methods, it gets a lot of people thinking, all right, how can we do this? Burning on scene seems to be the best way to get rid of the energy at the fire department level. Currently, UL data is showing it takes around an hour, hour and a half to burn through that battery pack. To note on that, there has been some recording of maybe still a few cells within that battery pack not burning, even though the vehicle did burn its way through the battery pack and self-extinguish or that sort of thing. So pay close attention to that. Time and space has been minimally effective. Reports of spontaneous combustion of electric vehicles 12, 13 months later. I know there were some that went from Florida out to California and had some issues like that. And then the water bath methods, you may have seen some of this. When you have a 1% saltwater solution or higher, or 1 pound every 25 gallons of sodium bicarb, that electrolyte mixture over time can draw the charged state out of the battery. Um, that's just dependent on the size of the battery, the time, the access, all that sort of stuff. And then again, you're still dealing with these dumpsters and what do you do with the water, the runoff on that. And one thing I missed on the time and space, generally the recommended 50 feet around the electric vehicle when it's in the tow yard. For reference, you can generally put 20 to 30 internal combustion vehicles in that same space. The white vapor cloud, or the smoke, so to speak, the vapors coming out of the batteries are not just your regular everyday smoke. The deflagration gases get a lot of attention, a lot of toxicity. CO, CO2, hydrogen, and hydrogen fluoride definitely get a lot of attention, especially that HF. And the hydrogen release, a low auto ignition temperature, so you only need around 300 degrees to get that thing going. So you don't need a whole lot of temperature there to have a reignition. You can imagine the challenges on the rollbacks and those sorts of things if you don't have a complete burn through the battery pack and you still have live damaged batteries. It's recommended to go back and refamiliarize yourself or familiarize yourself with hydrofluoric acid or HF exposure, some different things that are kind of odd about it. And then it's likely the next 10 to 20 years in the fire service to some degree you're going to be exposed to or potentially exposed to lithium ion batteries and different things. So some of the odd things: delayed onset, 12 to 24-hour reactions, cause pulmonary edema, irregular heartbeat, some different things like that. So we're just recommending everybody go back, refamiliarize yourself, know what you're dealing with there. Stop, think, observe, proceed. Piercing, cutting into the battery pack is not recommended in any of the ERG guides. There are some questions on liability at the department level if you are cutting into battery packs opposed to the ERG guides. And then the usage of wetting agents and foams is somewhat controversial. I can tell you on the new fluorine-free foams, the way that they're tested at UL, their burn back or how long they have to last on the flammable liquid is considerably longer than what it was for the AFFF foams, meaning if you're putting a heavy foam blanket over the top of a battery, you're likely insulating heat versus allowing it to dissipate and release. The wetting agents have shown to do a fairly decent job when you can get the agent to the actual battery pack. Um, in an electric vehicle, that's a lot of times often challenging to get the actual agent there. When you're dealing with scooters and different fires where you can get the agent, stop the propagation fire, and then you have something on the back end to overpack, safe off, deal with the unburnt, damaged batteries, the wetting agents can do a great job there for you. There's also some evidence that they're able to maybe clean up some of the smoke and some of the toxicity and that sort of thing associated with the lithium ion batteries. EV fire tactics. Number one, size up 360. Always size up 360, minimum 300 foot safety zone. If you're able, remove the keys. We understand if it's on fire, that's a little bit challenging. And then consulting those emergency response guides. The one thing we like to say there is if you're in an area that you don't have internet at all times, then you may consider downloading some of that information onto a tablet or something that you keep local on a truck. A lot of the ERG guides are tied to internet service. Establish incident command and tactical priorities, victim care, extrication. Is the vehicle on fire? Are we going to pull it out? Are we going to let it burn? Protect exposure, suppress. What's going on with this fire? What do we need to be doing here? Tactical priorities: when we get on scene, a lot of attention goes to using winches, J hooks, those sorts of things to separate the vehicles from the exposures. To that point, we absolutely recommend that. That's a great way. A lot of the dealing with this is confinement, isolation, allowing the batteries to do what they're going to do, and just kind of determining how quickly or how slowly you want to intervene in that. One of the things we like to point out is that the electric vehicles are considerably higher weight than their internal combustion vehicle counterparts. So when you're looking at doing some of these winching and J-hook operations, it's important to understand that a vehicle like that GM Hummer is at 9,500 pounds, and then something as small as that BMW i3 is still in the 3,000 pound range. We just want to make sure that people understand that the weight could equal challenges with winching, and also understand that likely if the vehicle is experiencing a challenge, those wheels are going to be locked down. They're not going to be rolling for you. So you could potentially be setting up a winching operation that gets somebody hurt or something like that. Just be careful and know what you're doing there. Secure your water supply early. Plan for 5 to 10,000 gallons of water. Spartan protocol generally requires around 1,500 to 3,500 gallons of water. That's to get the vehicle in a more calmed down state. From there, you may continue to apply water, or you may look at ways to shift that vehicle around, pull it out, drag it out, those sorts of things. Sure, proper PPE is used, bunker gear, SCBAs. Most people in their SOGs are writing electric vehicle fires require full PPE, SCBAs. Watch for that vapor cloud and the battery explosions. I'd like people to think about in terms of damaged batteries potentially can ignite off gas at any point. So if you're on an extrication, especially, this seems to be one of the more concerning areas. When you pull up on scene and it's on fire, we know the vehicle's on fire. When it's extrication, we're not really sure what's going on with that battery pack and how close or how far away are we from a potential thermal event. Have we ever done full training, especially in the hottest summer, and full PPE, SCBAs, all those sorts of things? Do we know how we move, our tools move, our bottles move? Are we clinking together? Can we actually verbalize and speak very well and communicate very well? Those sorts of things. And then should we be looking at, most people are pulling a safety line when they're doing an extrication. Should we be looking at maybe a gated wire on the truck, running a safety hand line and either some sort of nozzle under or something maybe interior of the vehicle in case we do get this thermal runaway, that we have something to apply some cooling water and maybe help try to protect the victim. So one of the things we like to show people here is that if you look at this video down here in the right hand corner, you're a good 3 to 4 seconds in before you actually recognize that maybe this is off gassing. At the 9-second mark, you can see this flash. We've watched these go for 5, 10, 15 minutes off gassing before ignition, and then we've also seen some of them go within the first 10, 15, 20 seconds. So there's really no way to know. You just have to kind of anticipate that this may go very quickly and be ready for that. Stabilize the vehicle, rescue if needed. The one thing to note here is that the motors in the electric vehicles have a tremendous amount of torque. 4x4 may not be robust enough to chock and immobilize an electric vehicle. Fire decisions, let it burn, can't let it burn. Got to figure out what we got to do here. This picture on the right hand side is a great illustration of allowing an electric vehicle to slowly burn itself out. This fire department did have a hydrant, so they had plenty of water there on hand. By deploying the nozzle and then feathering water in on the backside here to contain whatever fires on the top side of the battery pack, the firefighters were able to separate themselves, give great protection considerations to their gear, to the off-gassing and that sort of stuff in their gear, give plenty of distance and that sort of stuff for firefighter safety, and allow this vehicle to slowly burn itself out, protect the roadways and that sort of thing. And it did a great job for them dealing with that specific incident. Letting the electric vehicle burn. This is a great tactic, great way of dealing with the vehicle. If it's not threatening anything else, allow it to swiftly burn through the battery pack, consume all that energy, release all that energy, and then go through and put the rest of the vehicle out. It's a great way to deal with it. Secure your water supply early. Make sure you have plenty of water on hand. You may have a 3-5 hour operation depending on the situation, so make sure you got plenty of supply secured. Manage exposures, J-hooks, winches, remove if possible. Again, we talked about that. Big fans of using the winches and the J-hooks if you're able to. Stabilize, power down. Again, if you're able to, that's great things that you're to do. And fire suppression. We're always recommending an initial knockdown. You get that initial knockdown, you could potentially have an electric vehicle on fire where the vehicle interior or the vehicle contents is on fire, but you don't have the battery pack on fire. You could also just have the battery pack on fire. So you can have one either or. It's great to go ahead and get an initial knockdown so that you can understand what do we really have on fire, what don't we have on fire, and how do we need to continue to attack this fire, that sort of thing. Safety measures, plenty of distance for your personnel and your gear. Applying cooling water. If you're going to apply cooling water, consider using that EV nozzle again to give that targeted application. And then also there's considerations with roadway. Maybe, hey, it's in a spot that we want to let it burn, but roadway's consideration, high traffic area, that sort of thing. So considerations for the roadways and traffic and that sort of stuff. So heat monitoring, we're always going to recommend to go ahead and get out your thermal imager. It's great to take a thermal reading every 5-10 minutes in this situation. Go ahead and plot that on a graph. You'll go ahead and see kind of the curve. You'll hit that peak temperature and then it'll start kind of going down the back end. We're recommending that fire departments set their own SOGs. A lot of departments 150, 200, 300 degrees kind of on that back end. That's when they're calling it likely all the batteries are burned up. Go ahead and do the rest of your standard extinguishment, vehicle contents, and we'll go ahead and get this thing loaded up and get it out of here sort of thing. So look for signs of white smoke, continued off-gassing, indications of continued thermal issues. Post-fire actions, conduct firefighter decon on your gear for health and safety and on the firefighters themselves. And then we're always going to recommend to escort that tow. If you're able to escort the tow to the tow yard, just to ensure any, if anything else gets kind of squirrely, that you're right there to kind of deal with it. So this is showing you some of the data out of some of the FSRI, UL research and some of the stuff that they've published here in the recent few months, and some of the tactics and some of the things that they've gleaned. We'll talk about a little bit. So you can see some of the baseline data on the chemical heat release and the conductive heat release over the seconds from ignition. And then some of the things that they noticed, fog protected approaches and suppression lines. So if you're just going to use straight water, you're looking for maybe some of those battery pack or breaches and vents and that sort of stuff. It's a good idea to maybe use a fog protected to push some of that vapor away, keep that off your gear. And then one of the other things that they noticed was that opposing streams on that for that vapor compression did a great job, where if you're using one stream, that it was pushing that vapor away, and that if you needed to maybe try to confine it and compress it, that you could use opposing streams, and it did a fairly decent job at that. Okay, the next kind of option here is using that hand line again to do that initial knockdown, and then a department that maybe has an electric vehicle nozzle, such as our Sudsit or our Trident 250 or something in that range. But essentially, again, we're always recommending that knockdown. So firefighters go in, use that hand line, get a great aggressive knockdown. Best as they can. You may want to stay back a little bit. I'm not sure what your SOGs might be as far as how close you want to get involved in that smoke and vapors and whatnot. But irregardless, the goal here is get a great knockdown. Knock down as much of the fire as you can. Take down as much of the energy and the vehicle and contents and that sort of stuff. Knock down as much of that as you basically can. And then from there, you would go ahead and start working on getting the nozzle involved, getting that up under the vehicle, and going ahead and getting it operating and doing its thing there. And go ahead and see here, the firefighters go ahead and install the nozzle. You may want to do a vapor suppression or using a fog nozzle as you apply that nozzle, as you apply the UV nozzle, to go ahead and push those vapors away from the firefighters and that sort of stuff. This was pretty early on, so a lot of learning things going on here in this. This was in Chattanooga, Tennessee. We were able to go up there. Volkswagen donated some electric vehicles for us to burn. Chattanooga experienced a pretty significant electric vehicle fire in a parking deck. Everybody's kind of big concern or worry. Had some challenges, so we're up there deploying some different tactics and that sort of stuff. You can see here in a minute, or they got the nozzle going. It starts pushing a lot of that vapor out and calming down that situation. In this fire, they used basically an acetylene torch to punch a hole in the underside to get the vehicle in a thermal runaway. Due to the nozzle and that breach point, we actually did stop the thermal runaway in this specific test. Now onto the Spartanburg protocol, utilizing handline for knockdown, EV nozzles, the blanket combo. Phase one of this would be your vehicle and content suppression. That's where you're going to use your handline and just try to isolate the fire down to the battery pack, knock out as much heat as you can. And then phase two is that battery isolation and cooling phase where you're deploying the nozzles, the blankets, and the handline over the top of the blanket to cool that vehicle and calm down the fire. Protocol development history, late 2022, early 2023. Chief Pruitt experienced some issues, some fire issues at distribution points and at the factory there. He was using the original water bath method to start, knock it down best as you can, drag it out. If you can put a load on the battery in the form of windshield wipers, lights, horns, whatever it could be to try to deplete the batteries. You would try to do that, and said that he sat there and watched vehicles submerge for 3 and 4 weeks with the wipers going and that sort of stuff, and just kind of felt like that wasn't a great, necessarily a great way to deal with the fires. Some of the challenges experienced using the water bath method: the plain water does nothing for the stored energy. As you recall, the electrolyte solutions can, but the plain water does not do a whole lot for it. The EVs only lose the EVs, or I should say the lithium ion batteries, only lose 2 to 3% charge state per month. So they're not depleting their energy very quickly, which is one of the reasons the technology is used and enjoyed in a lot of other areas. Once the vehicle is removed, the terminals could potentially corrode. So that water that was in there that got into the battery case could then potentially corrode the terminals, leak the electrolytes, and then potential reignition on down the road after you've taken it out of the water. So didn't prove to be all that great of a method as far as truly dealing with the entire situation. So Chief wanted a new approach to save time and money. He went asked his boss for a fuel load to burn. He was given 8 electric vehicles to go ahead and burn. That's equal to about $500,000 worth of electric vehicles at the time. He purchased all the nozzles, blankets, all the solutions available that he could, and went out and kind of started doing this testing process of trying to figure out how would they be able to deal with these in various different areas inside the plant, inside the distribution areas, and that sort of stuff. So the first thing they did is we'll go ahead and get out the blankets and start a fire and put a blanket over the top. As you can see from this video, put the blanket over the top, let the electric vehicle get a decent pre-burn. Not a great pre-burn. You can see very quickly the fire burning through the blanket. Our experience has been, along with a lot of other fire authorities that have done this, lit a vehicle through a blanket over the top, was that you very quickly burn through the electric vehicle blanket. You can see here in this video, this is the next one. Maybe the blanket was just bad. We'll try another blanket. You can see with vertical heat rise, it makes it hard just to even hold a blanket down over the top. That small explosion that you had there, again, lighting the electric vehicle on fire and just putting a blanket with no early intervention, no knockdown of the fire, seems to be very challenging. Here we are again showing one last deployment of an electric vehicle blanket with no intervention, no knockdown, that sort of thing. In this scenario, again, we were out here in Chattanooga. This specific manufacturer did not think that they needed a knockdown or would need a knockdown with their specific product. You can see here again, a vertical heat rise makes it challenging for a firefighter to hold the blanket down over an electric vehicle. Some of the FSRI recommendation was to go in front of, so as those guys are pulling that vehicle, to be in front of it with a hand line, applying cooling water, knocking those and condensing those vapors down, that sort of stuff. So at a certain point here, it gets basically too hot and too hard for the firefighter to hold the blanket down, and he just goes ahead and lets go of it because all the heat coming out at him. And all the vapor exposure and that sort of stuff. And you can see as it goes along, it ends up kind of burning up the blanket, destroying it, and didn't work out all that well. You can also see the proper importance of practicing with the blankets to apply them before your first actual application, that sort of stuff. So. So after burning up the blankets, next thing that they did is, okay, well, the blankets didn't work out very well. Let's go ahead and try to light some on fire, and we'll put the nozzles up under there and kind of see what effect that has on it. See if that'll do it, if that'll stop the fire, put it out, that sort of thing. Unfortunately, we don't have any video of that currently. However, Chief Pruitt experienced something very similar to this picture that you saw earlier that we spoke about. The nozzle up under the vehicle did a great job covering the underside of the vehicle, protecting the roadway, the structure up under it. It absolutely did nothing for anything over the top of the vehicle and content. So you could imagine in a manufacturing setting or something like that having a raging fire on top wasn't going to be a full solution for a fire chief in that position and that sort of thing. So, however, the good takeaway from that is a nozzle under protecting roadway, allowing it to do its thing and just kind of calm and secure the situation does a great job. So after burning up 250 grand worth of cars, half the fuel load, and knowing that they had some of the larger fire authorities that have distribution points, FDNY, Jacksonville, San Francisco, some of these large port cities, headed their way to kind of teach them some tactics. Part of this whole exercise was to hopefully give some tactics back to these fire departments to help if they had any issues in the distribution points and those sorts of things. So after burning up half the fuel load, they didn't really have a whole great, much of an idea exactly what to do. Had very little success with the blankets and the nozzles. And as the story goes, somebody at dinner was kind of saying, well, hey, maybe, why don't we just start maybe fighting like a car fire, like a regular car fire? At least maybe that kind of knocks down the heat, protects the blanket, that sort of stuff. That's where this whole kind of Spartanburg protocol got going from there. Preliminary steps, making sure that you have plenty of water, backup on scene, make sure you have all that kind of coming into stabilization, isolation, make sure you got that video or that vehicle in a pretty good spot there if you're able. On the phase one, vehicle and content suppression. So that first thing you're going to do is just going to do a knockdown, just like you would any other car fire that you've ever fought, 45-degree angles, all those sorts of things. Fog protected approach, potentially, that's some of the FSRI stuff, maybe looking at some of those opposing streams to condense some of that vapor if you need to, potentially looking for vents and breaches in the battery pack for cooling, but also understanding if I do get in there, if I do stop that propagation fire, I have all those damaged batteries, I need to have a plan in place for that. So that may not be the best tactic for today or the situation. So just understanding that. And then again, knowing that it's critical to get as much heat out of the vehicle before you deploy the blanket. Phase two, onto the battery isolation and the cooling side, the blanket application on the right-hand side. You can see some of these FSRI graphs and some of the stuff there that they plotted out. Radical atmospheric reduction, 5 to 10 minutes from some of those studies. And then some different things with reduced gas emissions by 60%, flame spread by 85% from some UK studies. So showing the effectiveness of the blankets. You can again see this is one of the first times that any of these firefighters had applied the blankets. The more that you practice with them, the easier you can get them on exactly how you want them right from the start, so you don't have any of this fluffing the edges and any of this gas exposure, any of those sorts of things. You could potentially have that hand line on the other side with the firefighters there pushing some of that vapor away and that sort of stuff. So some different things there as people get more comfortable and do these sorts of operations and have more experience with it, that sort of stuff to take away. So this was very much a learning exercise. You can see there some of the vapor load that the firefighters take on by that we can prevent if we have the blanket in place exactly where we want it from the very start. And again, you can prevent maybe some of that with that hand line as well. All right, after we get the blanket over, we want to continue those handline ops over the top of the blanket, continue that cooling trend, protecting those seams, and then go ahead and get that nozzle installed up under the blanket fairly quickly right there as we get it all in place. In this specific incident, you'll see there was a challenge. This vehicle had already fallen on its side, and they weren't able to get the vehicle or the nozzle all the way up under the vehicle to spray directly on the battery pack. You see the guys kind of trying to adjust the nozzle. It actually was just pushed up against the rocker panel there on the passenger side of the vehicle. Which brings us to an important point that at a certain spot, generally the structural arms, the suspension arms will fall out, and you potentially are faced with the vehicle sitting flat on its belly. So when you get to an electric vehicle, or if you're looking at nozzle purchases, understanding that having something that goes under, but also potentially inside with the ability to put a blanket over the top is something that could be potentially important. You see again here that the nozzle is showing highly effective at substructure and ground cooling, according to some of these studies. And then again, reduced thermal runaway and propagation by 70% compared to traditional straight stream when using a targeted electric vehicle nozzle. Now that we got the package put together, we're kind of more into that cooling phase. This video is just showing the first 15 seconds of the first minute or 3 minutes of application. You can see the vapor, how it starts to clean up the vapor. Some of the considerations here is number one, tucking or not tucking the blanket. We're not necessarily recommending one way or the other. I think some of it depends on the situation. The things to kind of know about some of that is number one, water pooling risk. So there is a potential if you have a truck or something that could collect water, that as you're flowing the water over the top, that you're pooling it, making it harder to remove the blanket later on. So be cognizant of that. Maybe you just go up if it's a truck version that you're dealing with and open the tailgate so that you don't pool water there. Tucking the edges, potential increased deflagration vent potential just due to more trapped gas, more high vapor levels, that sort of thing. And again, venting the edges could also, with the nozzle up under there, you're potentially pushing out some of those hot gases. You need to be kind of cognizant of where you're at, that those gases being pushed out from under the blanket could potentially set up a secondary confined space where you have a gas range concentration, that sort of stuff. So things to consider there. This here is just a quick simulated video of the Spartanburg protocol. You can see simulating the initial knockdown. The methodology of folding the blanket back, you lose that vertical heat rise, so folding the blanket back on itself helps you apply it. Third away on the vehicle, going back to those rear handles and kind of flying it up over the vehicle does a great job. Hand line ups over the top of the blanket, watching those seams with your thermal imaging camera, and then getting that nozzle up under the vehicle to go ahead and start that cooling process or slowing that propagation fire. What's happening under this blanket? If you were very familiar with this and watched a lot of this in the early days, you knew that the batteries threw off oxygen as the metal oxides decomposed byproduct oxygen, meaning that they can burn underwater, they can burn outer space. So the idea of putting a blanket and suffocating a battery fire was pretty silly. And again, it is pretty silly. It doesn't work like that. And then number two, if you knew much about the battery pack construction, you knew those batteries were down inside a couple layers of metal. So the idea of spraying water at the underside and getting it inside the battery tray or that sort of stuff and stopping a fire, again, was kind of silly. And to that point, it is. So what's actually taking place in all of this is not necessarily that, and this maybe helps people digest it a little bit better. So that initial knockdown, what we have observed is you're getting around 400 or 500 degrees internal temperature of the vehicle. So you're taking out a tremendous amount of the heat of the overall fuel load. And the other way to kind of think about this is of that 100% fuel load, 30 to 40% of it is battery. 60 to 70% is vehicle and content. So just by covering it, you've essentially reduced that fuel load from 100% to 30 to 40%. But you get the blanket over the top. That's doing two things for you. It's creating a cooling space. So as you get the nozzle under there, you have a nice tight cooling space. If you can get the temperatures down below 212 degrees, you significantly drop or reduce the thermal runaway or the propagation fire that you have taking place inside that battery pack. And then the other thing that it's doing is by having that blanket over there, it's preventing the rest of that vehicle and contents, all those general combustibles that need the oxygen. So you've isolated and kind of calmed down the total fuel load there. What we're noticing is around 30 to 15 to 30 minutes of application is calming that fire down to the point that it's kind of getting to the point where it's hard to tell, is there a lot of fire still going on. We have stopped propagation fires, maybe breaches and that sort of stuff, and we have had some that just kind of continued to burn themselves out under this protection. This is also a great illustration up here in this picture of that hot spot. So you get out your thermal imager, you're watching the outside of this, you're hitting the outside of it with your hand line. That's showing you those hot spots where you want to protect the seams in your blankets and those sorts of things. So great illustration here. Okay, signs of precautions here at the end. You'll see this burp, flash, whatever you want to call it. I think there's some different terms for this sort of thing. Want to make sure people see this and see this possibility. We'd like people to be away, set this up, let it kind of do its thing, keep your firefighters back. That keeps them away from the gases. That keeps them away from a lot of these different potentials. From some of the FSR studies and that sort of stuff, one of the big main kind of things that came out of this was when you're using the blankets, when you go to remove them, in case you do have some of this flash, backdraft, deflagration, whatever you want to call it, use 50, 75-foot leads. So you're pulling the blanket off from some distance in case you get this flash, that sort of thing. So again, always recommending careful on the blanket removal, full PPE, all those sorts of things. Watch for that hissing, popping, white smoke, all those sorts of things as continued thermal runaway. Post-incident econ, always recommending that for the firefighters, health and safety on their gear, and an escort net tow. Always want to recommend escort net tow to the tow yard. There was an immediate safety advisory that went out earlier this year, 2025, about the use of blankets and some issues that had been or that had taken place in some of the testing and that sort of thing. Some of the key takeaways was that the deployment of the blankets eliminated flaming by denying oxygen to the vehicle battery fire, continued release and accumulation of flammable gases under volume under the blanket. In some of the experiences, the accumulation of flammable gases under the blanket presented an explosion risk to firefighters operating near the vehicle. The risk of an explosion can be increased when reintroducing air into an oxygen-depleted accumulation of unburnt flammable battery gases. So just want to point that out. And now here on this, you can kind of see what happened in this situation that put out this advisory. This is a video from the actual test. You'll see here the guys are actually pulling around on the blanket, and there you go. That's what kind of put out this advisory. My understanding what happened here in this was the battery pack, it had vented, it had burned itself all the way through. In this, the test was over. The guys were going to clean this up and everything. It was considered that the test was over and that sort of stuff. So our understanding what happened was that the battery pack itself, the vents had burnt out due to the lessening of the fire. It still had a high level of vapor inside there. As the guys went to remove the blanket, there was an account for the pooling. So the rear end of this Rivian filled up with water, the rear end of the truck, making it hard to remove the blanket. As the guys were tugging and pulling on it a few different times, and there was more before you see this happen, that allowed enough oxygen to enter into the actual battery case itself. Once you did that, enough heat, and they went ahead and had the reaction that we had here. So it's great for people to be able to see that. Again, that's part of this with the leads, part of the considerations, if it's a truck, pooling, those sorts of things that you could potentially have as you float water over the top of the blanket and that sort of thing. So next was to touch on active battery pack suppression. So if you are going to get in some of these really high threat areas and you feel the need that you're going to need to get inside of a battery pack, you need to try to pierce, cut, use some aggregate cutting tools, high pressure, low volume, that sort of stuff to get into the battery pack to hopefully stop the thermal runaway, stop the off-gassing, that sort of stuff. Some of the considerations, non-conductive piercing applications appeared to be effective. Multiple penetrations were required to go into the different battery modules. Abrasive materials have limited supplies and require shutdown and reloaded. Hand lines were imperative to knock down gases and those sorts of things as the lance operator was operating. They were able to use significantly less water, around 300-gallon range, and then timeline is competitive with traditional tactics. So some of this slide kind of touches on some of the active battery pack suppression and that sort of stuff. You can see some of these videos down here, the proximity that somebody would need to be in with the electric vehicle if you're going to get into some of that sort of activity. So Just like people to understand that. And then also like to kind of point out some things here for understanding that if the general consensus that UL kind of put together is that it's about an hour, hour and a half for that battery pack to burn through, as you're kind of factoring into what your response is, what stage of the battery fire you are, electric vehicle fire you're in, should kind of factor into your actual what you're going to do, I guess, is what we're getting at here. And just kind of looking at this, you'll see average NFPA response, 2 minutes until 911 gets a call, or dispatch gets a call. NFPA has an 8.5 minute average response time. So somewhere in around that 10 minute before you get there, get a quick 360, maybe you can get some water deployed, something like that. We're in that 12, 13 minute range, just kind of off some standard NFPA kind of numbers. When you start kind of looking at all that and you look at time from start to what percentage of battery pack is remaining, in this just kind of average scenario, you're at 60% of the battery pack left, 40% consumed. If you get out into a 25, 30 minute response time before you can actually start doing some of these applications, let's say it's a car park, a parking deck, you're going to try to get a vehicle up there, limitations due to smoke, internal combustion engines, those sorts of things. Just kind of factor all this sort of thing into that response, and are you able to actually stop what you're going to do? So stranded energy challenge, potentially on the back end, have something in place. If I stop the propagation, now what am I going to do with all these live charge damaged batteries? What percent of the battery pack remains once an attack can be made? Not recommended by the ERG guides is their exposure and liability at the department level with doing some of these things. What is the risk associated with the turnout gear investments that we have and equipment costs? So just some of the things to kind of think about there if you need to get into these sorts of activities. Some of the kind of blanket usage takeaways and then overall takeaways from the research that was done and presented earlier this year. So the blanket usage takeaways: extreme caution when removing blankets, lifting edges, that sort of stuff. There's some debates on whether it should be tucked, whether it shouldn't be tucked, whether once you put it in place, should you ever take it off, or that sort of stuff. So different things there, different guidance maybe. Recommended to use that 50, 75-foot leads when you're removing it. And then again, full PPE and all those sorts of things for the firefighters as you're removing it. And then look for maybe some coming guidance on potential heat and gas readings and that sort of stuff. So maybe some tick validation readings and maybe some gas readings in those natural venting areas and some stuff too. So then the preliminary summary coming from the research foundations: overall encouraging results. Each tactic tool had different pros and cons and trade-offs. Most of them manage incidents with less resources than previous claimed as needed. And then disparity in residual stranded energy. So different kind of challenges there on the back end of if we stop a fire, then we've got another scenario that we've got to deal with sort of thing there. Anticipated outcomes, better understanding performance and suppression tactics on EVs, data and informed best practices and that sort of stuff coming, updated training for the fire service, so some more kind of tactics and that sort of stuff coming from NFPA, FSRI, those groups. Now we're going to delve into a little bit of the toxic suppression product line and some of our different products and selection guides, and then how we derived our equipment and where it came from. As you'll see throughout this section, we have a diverse range of nozzles: small, medium, large. We have blankets, and we also have lithium-ion overpacking products as well. So a wide range of products to deal with all your lithium-ion battery fire challenges. Talking about the nozzle itself, or when you're looking at a nozzle selection, there's a lot of science that went into the Sudsit EV nozzle. This is the first patented nozzle available for the fire service to target electric vehicle fires, the underside. In the original days, and kind of looking at this and developing the nozzle, we did a couple things here. So our kind of feeling or take on it was when you're spraying from the underside of the vehicle, you only can have around a 16th inch layer of water or so in contact with the bottom side of that tray at any given second. So it's kind of our takeaway that any more water outside of that wouldn't be put to great use and would be more runoff water than necessarily water that could be used absorbing BTU, cooling that propagation fire battery tray, that sort of thing. So in this 11 foot by 6 foot square footage, what you notice, or what you would get if you calculated a 16th inch layer of water, is it requires that's about 1 gallon of water. So we originally set the nozzle up at 70 gallons a minute. They're essentially giving you a 16th inch layer of water on the underside of that battery pack at any given second. The other thing that we kind of calculated or took into account was that one Tesla battery module at the time required about 68 gallons a minute to combat the BTU load output potential of that battery module. So at 70, we had both those parameters covered. The other thing to note is the nozzle sits at 2.5 inches. If you come over here on the left-hand side, and if you want to, you can look at evspecs.org. But what you find is that 70% of the vehicles are 7 inches or below, 41% 6 inches below, meaning that by the time you get on scene, those heights are calculated with tires. By the time you get on scene, you're looking in that 2, 3, 4, 5 inch range, potentially up under the vehicle when you get there. Meaning you might not have a space to slide the nozzle up under there, or very little space on some of these vehicles. The standard municipal nozzle is designed to be modular in design. You can use it for many different things under the electric vehicle, in a crawl space, anywhere you've had a firefighter applying vertical water. You can put this in place, and now that firefighter can go do something else for you on a fire ground. Interior of an EV, there's a way to configure the nozzle so that you can hang it over the door, over the window space, allowing it to apply water interior of the vehicle, allowing you to put a blanket over the top while still applying cooling water inside. That's especially important if you get on scene and the vehicle's already fallen flat on its belly, not giving you this space to slide an electric vehicle nozzle under the vehicle itself. There's attic loft or attic cellar nozzle attachments, piercing attachments, and decon potential opportunities. So in the early days of the nozzle, we set it at 70 gallons a minute. We had some different fire departments thinking maybe it should have more flow and those sorts of things. Instead of arguing, our engineer developed a choke system, kind of like you have a shotgun. So you have the capability to adjust the outflow of the nozzle from 70, 85 to 100 GPM. That's more before you put it in place. It's not necessarily an on-the-fly adjustment. These GPM flows are calculated at 100 PSI on the tip of the nozzle. And to convert the nozzle, you may need some of the component kit packages. We do sell the nozzle as standalone nozzle itself, and then we sell it with the extended parts or the added parts to be able to build some of these other configurations. Here's our EV interior door hanger nozzle. We've done some different things with this nozzle and some different testing and whatnot. So it's great for the interior of an EV when it's on fire. You can put the blanket over the top. There are going to be times where you get on scene where these support arms have burnt out and the EV is sitting flat on its belly on the ground. So if in that situation you needed to apply water in a blanket, this gives you the capability. We've also done dumpster fires. We've done some hydraulic ventilation, some different things that you're able to do with that nozzle configuration and apply water interior while preventing firefighters from necessarily being so close. You can see here the attic and attic, cellar, and shower configurations. Just giving you more versatility so that the product's not a one-trick pony on your truck. There's a lot of different ways that you're actually able to use it out in the field. $250 a minute model. This is an inch and a half connection, 40-inch extension poles, very similar to the original. This does not have the water curtain on it, but if you need larger flows or you have plenty of water, this is a great option as well. 500-gallon a minute nozzle, 2.5-inch connections. Big Water 500 was designed more for buses and some of these larger applications, that sort of thing. The nozzle is designed as a very flat broadcasting pattern, so you can't get up at 40 feet to the right, 40 feet to the left, or an overall total 80 feet of coverage. Water demand volumes, you can see kind of some of the calculated out here. I really like that smaller nozzle set up at 70 gallons a minute. It's worked out really well in the field for Chief Pruitt, other departments that have used it. That first number at 500 gallons a minute, that phase one cooling estimation. And you can kind of see here in that 15 to 30 minute range, you're somewhere in that 1,500 to 3,500 gallons of water. Again, 70 gallons a minute on the nozzle. I really like your hand line ops over the top around 30 gallons. That's kind of roughly 100. That gives you some of that easy tank water calculation, that sort of things. It seems to work out fairly well. Most people are reporting somewhere in that 15 to 30, 20 to 40 minute range to kind of stabilize the vehicle, slow down that propagation fire, and then be kind of in a spot where you're looking to maybe look at do other things or continue that operation where you're at. The blankets, fire security blankets, we recognize that they're not suffocation instruments or devices. We want to make sure to point that out. They're more of a fire security, heat shield, BTU absorbing kind of piece of equipment to help buy you time and to help protect structures and exposures.
Thank you for your purchase of the Toxic Tarp Fire Security Blanket for EV. Thank you for your purchase of the Toxic Tarp Fire Security Blanket for EV fires. As EV fires pose new challenges, please follow these instructions for best results. The 20 by 26 foot toxic tarps come in two styles, a 1100 degree silica coated fiberglass and a 2700 degree carbon fiber. Toxic tarps have seam guards for durability that are color coded to act as a visual indicator of proper placement. The grab handles are color coded to assist in orientation, and the center handles are offset to assist with placement, while the XL 1.5 inch grommets allow use of a pike pole and tie down post incident. We highly recommend initial knockdown of the standard vehicle contents fire. In order to remove as much heat as possible before placing tarp. Unroll and stage tarp at the front or rear of the vehicle. If possible, apply from vending side as indicated in vehicle's ERG. Remember, initial knockdown to remove heat is key. Start by orienting the tarp with the green handles facing forward, aimed at the vehicle. The yellow offset handles should be used as a reference for where the blanket should fold when you pull back on the green handles. Next, grasp the yellow handles to lift and guide the tarp onto either the front or rear of the vehicle, depending on scenario. Now grab the green handles and pull the remainder of the tarp over the rest of the vehicle. Ensure the tarp is centered in all directions, then tuck the edges under and around the vehicle to prevent standard contents from rekindling. Flow a low GPM hand line over the tarp for protection while charging a recommended EV fire nozzle and inserting it under the vehicle to cool and isolate the fire to the battery pack. Monitor with a thermal imaging camera until temperatures are stabilized or batteries are consumed. Thank you for your purchase of the toxic tarp.
EV blanket questions and considerations. One of the first and biggest questions, single use or multi-use. I would kind of comment on that I think most of the general consensus at this point is that electric vehicle blankets are single use. Some of the questions there that kind of determine some of this is, number one, do you want to put that dirty blanket with these chemicals on there and that sort of stuff back on your truck for your firefighters to reuse and maybe be around? This one's a big one to me, is performance verification. If you were going to roll that blanket up and reuse it, how did you determine that it was still good? And without UL and FPA, some sort of regulatory agency saying this is how you would do it, I find it hard for a department to take on that liability of saying, yes, it's good, no, it's not good, that sort of thing. Blanket washing decon on site. Can the firefighters clean it on site after the fire? That's still up in the air. My understanding is some of the colleges and universities are looking at that. Can you send the blankets off to a UL listed ISP that washes and repairs your gear? That would be great. Maybe future considerations. I know the ISPs would love to do the business, but right now there's no kind of verification on how you do it from UL and FPA. There's no testing on cross-contamination of washing machines and that sort of stuff. So there's still a lot of liability that need to be worked out in order to do that. And then should the EV blanket go with the vehicle to the tow yard? And if you remember, there are instances where electric vehicle battery pack burns its way through, but there are still some live cells in there that didn't burn, and could potentially reignite. So it might be a good idea to have those vehicles or those blankets over the top of the vehicles in the tow yard in case you do get some of those extra batteries or something like that. So something to consider there. And then inevitably the next question is, how do we pay for it? Very expensive for single-use items. Can be somewhere in the $1,100-$1,200 up to $3,500 range. So can be very expensive items for single use. Cost recoup, insurance billing. So there are some departments I've spoken with that have abilities to work with their tow operators, who then bill insurance for blankets and those sorts of things, and they can cost recoup that way. And then also, a lot of cities have city ordinance or the ability to get more leeway when they have a hazmat incident. That seems to be the way that a lot of fire departments are trending, and to me, it sets up a pretty good kind of scenario for people. So if you kind of look at it in that way, then number one, as you start to purchase blankets, nozzles, and that sort of stuff, maybe you're not buying something for every frontline engine. However, all the hazmat engines and that sort of stuff now have blanket nozzle capabilities. You want to, a lot of people or a lot of departments are writing in their SOGs that all EV fires are hazmat scenes, because more for the cost recoup of the blanket, some of those sorts of things, if they ruin a set of turnout gear, that sort of stuff, now they have that report written in the way to do that. And then what that does in implementation is allows first do's job, all right, electric vehicle, radio for hazmat. Our job is to knock the vehicle and contents fire down to the battery pack. Hazmat's going to get here. Now we have a lot more hands on scene to throw the blankets, the nozzles, do some of these different things that we need to do. And then we have that ability to write the report. So that's worked out fairly well. Also, I'm trying to talk to state fire marshals that maybe there will be in the future a pool of money available that allows you to recoup blanket costs fairly easily, without maybe some of the rigmarole of the hazmat sort of thing. I do understand maybe sometimes the hazmat recoup is a little bit challenging. So that may be something in the future. I think that needs to come from the state fire chief or the fire chiefs and that sort of stuff to the fire marshals that, hey, we need a little help here. Can we tap into the insurance, and are there reports that we can write or information we can give back to the insurance side to kind of make a trade here, that sort of thing. I also, a lot of the evidence is that the electric vehicles burn less than the internal combustions and those sorts of things. And to me, that's a great point of, well, then this pool of money doesn't need to be very big. So maybe there's some things there, and then grants available as well. We call this Beware the Dutch Oven. It illustrates a couple things. Number one here, that if you don't have that knockdown, you see the flame impingement there in the ABC post area, that you don't want to have. And then again, if you don't have an appliance to slide under here to apply cooling water, you're forced to do an activity like this. That's all battery gas that's going on your firefighters in their turnout gear. And then right here is a great illustration of having your thermal imager, seeing those heat sinks or the heat areas on the blanket. That's where you're going to want to be hitting it with your hand line as you get that nozzle under there and all that sort of stuff. So what to expect when dealing with electric vehicle fires? My kind of opinion is it's more of a management than an extinguishment. You're kind of surveying the situation. You're figuring out how quickly or how slowly do we want this battery pack to burn. That's a lot dictated on the situation, how much exposure, how little exposure, all those sorts of things of what exactly your intervention needs to be or what it should be. And to me, it ends up being kind of an if-then kind of situation. If nothing's really threatened, let it burn. If it's structure and stuff, maybe you can use a blanket, nozzle, hand line, those sorts of things. Or maybe there's some specific areas where you really need to get in there and be aggressive and go ahead and try to get into that battery pack and stop that propagation fire. So deployment orders, tactics may change due to the situation. So be ready for that. Understand kind of what the parameters are so that you know what tactics and what products to deploy and that sort of thing. And then also understanding that the blankets are likely nasty. This is a great illustration of how it kind of nasty, potentially get some seam splits if you're not careful, you're not protecting that very well. You can see up here, you have potential to have airbag, hydrogen explosions and things split the seams. We did in our blankets, I didn't touch on this earlier, do a double needle, double feld in the seams here. So you can kind of see here on the back side, two seams running through there. Or I'm sorry, on the front side, two seams, on the back side, just one thread. One of those threads in that double needle, double felt is rolled up in the material to give it extra protection. So some things there to kind of look at. Here's some of our more notable larger major metro customers and that sort of stuff. We have quite a few that haven't been added to this list yet as well, and more growing each and every day. So this is a nozzle, this is blankets, this is both. It's kind of all over the map depending on the customer and that sort of thing. Okay, from here we're going to talk about some things that may be a little bit more controversial, but we're just going to explore them so that people can kind of understand them and think about them a little bit on their end. There may be some people that take the position that once you put a blanket, nozzle, all that sort of stuff in place, that you don't go take it, touch it, that sort of stuff until you're way on the backside of the heat sink and situations calm down and all those sorts of things, fires out, that sort of stuff. So we're not necessarily recommending one way or the other. We are going to explore some different things here. So Chief Pruitt is using this method, has used this method here with the wheel dolly jacks. If you did want to get into something like this, some of the different considerations would be make sure you have everything out of the way. If you're going to move a vehicle after you've kind of knocked it down, calmed it down, got it in a really good spot to a new location, less threatening location with these wheel dolly jacks, make sure everything's out of the way. We like the idea of raising the venting side. So if you know the venting side, generally that rear end, raise that first, give it a second, see if it's going to kind of get a little bit more angry, that sort of stuff, or what's going to happen there. And then go ahead and make the move, raise the front end, go ahead and make the move, that sort of thing. So it was kind of exciting. We did Carmel, Indiana, I guess, had a fire in a dealership, and there were some videos online of them using some of the wheel dollies and that sort of stuff to go ahead and get that vehicle outside. So pretty neat. Removing the hazard from an exposure, again, stabilizing the battery fire, using the wheel dollies, that sort of stuff, and then moving that hazard in an area without exposure concerns. You saw this picture earlier. You might not have noticed it, but you've got kind of the car there with the wheels tucked, the wheel dollies up under there, all those sorts of things. So a quick video just to kind of show you what the wheel dollies or the wheel skates kind of look like. There's a couple different products available, some different things. I just put some different products in there just to give some different ideas. I think it'd be cool if something like this kind of folded up very small and didn't take much room on a fire truck. Maybe it was a wheel dolly, wheel chalk kind of thing that could give you a robust wheel chalk as well. So we're looking towards the future to some firefighter to invent that product. And then here, this is a GoJack product. Chief Pruitt actually uses this. I don't think those wheels would do good on paved surface highways and stuff, but that's available. And I know that company is working on an electric vehicle model, or just came out with an electric vehicle model or something for the higher weights. So potential's there. And then that gets us to the inevitable part of most firefighters kind of looking at this when you're sitting in a presentation and noticing that most of their fires don't occur in flat, level, paved concrete surfaces, making it easy to roll a vehicle around. Most of them are incline, decline, whatever kind of surface, that sort of thing, making some of this more challenging. And this is where we kind of had, I would consider kind of our aha moment, as we're kind of searching around, trying to figure out maybe some ways that you would be able to deal with a vehicle that you've knocked down, calmed down inside of a car park or one of these areas, and that sort of thing. So, and we searched the internet for a while, looked at different ideas. There's robot valet pieces of equipment. There's motorized pallet jacks that have wheel lifts on them. There's a bunch of different stuff, but there was nothing we could really find that we thought, well, hey, that'd be easy for the fire service to use, or that sort of thing. So our aha moment kind of came when we realized that the way that most of the time you get a vehicle that's broken down in a car park or a parking deck right now is to use the older style tow trucks with the wheel lift and the hook on them. And then from there, we realized the repo industry has some pretty cool little wheel lifts that you can strap on an F-250, F-350 support vehicle type thing, and that there could be potentially the ability for fire departments to start doing some of their own movement, towing, dragging of vehicles with some of this equipment. So that was fairly interesting. We could also see maybe some of the larger municipalities. Some of them have their own tow trucks, or maybe you would spend on a used tow truck or something like that to give yourself capabilities like these. So if you did get into doing something like this, there's a couple things that we would recommend. Number one, make sure everything's out of the way. Make sure you removed everything out of the way that you're going before you start to do anything. Uh, Number two, if you had a vehicle in a parking structure in an area that you couldn't get a wheel lift to, maybe you could consider using wheel dollies to reposition that vehicle to a spot that you can get the wheel lift to and then get it the rest of the way out of that structure away. So things there. And then again, always recommending on the back end uh, proper PPE. Maybe possible to escort the move or the tow with handline protection. So maybe take a look at that. And then again, once you get the EV to a new place, if you're going to go ahead and remove that blanket, full PPE, watch for those flash fires, that sort of stuff, and then be careful when you're removing that blanket. Use those leads and all the extended guidance there. Here's a quick visual, just kind of pulling all that back again together. Car park on fire, getting in there, knocking it down with the hand line, deploying the blanket to nozzle, calming it down, maybe using wheel dollies to reposition the vehicle, then maybe using some sort of tow equipment, wheel lift equipment to get that vehicle on the rest of the way on out of there. Here's a quick video showing some of that repo equipment. If you've never seen a wheel lift like this, I kind of look at this and maybe see a little skid unit sitting in the back. And if you did kind of pick up a vehicle, maybe somebody's feathering water in case it gets angry or takes off or something like that, kind of escorting the grab or something like that. So anticipated costs or expenditures. This is really exciting once we got it all put together. And very early, there was a piece of equipment released that was in the 20 to 30, $40,000 range. So it felt like anything that was going to be released would be to try to deal with this would be very expensive. And after kind of digesting all this, nozzles in that 2 to 5,000, blankets 1,500 to say 3,300, wheel dollies 500 to 1,000. You can get yourself a nice kit to deal with a lot of what you're potentially dealing with for $3,500 to maybe $5,500 per truck. And then if you started looking at maybe some of those wheel-mounted wheel lifts and some of those sorts of things, those are 8 to 15 grand. BAs are 8, 9, 10 grand a pop right now. So we're not talking tons and tons of money for the fire service, which was pretty exciting once you kind of got all that together. Gross decon on the turnout gear, hydrofluoric acid, some of these other nasty constituents in that vapor and that sort of stuff. It's looking like it's going to be a good idea to go ahead and get as much decon going as soon as you can once you're done with the fire. Toxic Suppression was started as a firefighter health and safety cancer initiative type company, kind of being aware of that. We do have what we consider our decon journey. We'll briefly touch on that. Starting in the bottom left-hand corner with our preliminary exposure. As soon as you come out of the fire, it's a great idea to not take your mask off, to leave your mask on. Go ahead and wash down your gear as much as you can. Cool down your gear. That reduces the amount of VOC, that sort of thing. Even if you can doff your gear and bag it before you take off your SCBA, that's a great methodology to trying to mitigate some of that exposure at that point. Next thing you're going to do is hop in your fire truck. You are off-gassing VOCs. The case studies we've done so far, firefighters and BAs spike that VOC limit above recommended breathing levels for around 3 hours. With these ionization units that we have here, we're able to reduce that in around 10 minutes. Back to a recommended breathing limit. The units do run off an ionization technology that is regulated so it doesn't produce ozone. That allows you to actively be in the space with it, and it also makes it to where it doesn't require a bulb, a filter, a sacrificial part that makes a maintenance headache and or a replacement part that needs to be replaced in order to actually get the benefit from the unit. So 2 key benefits there. The units do actually clean themselves periodically. We have them available for EMS. The small unit you see on the bottom is great for the front part of the EMS. The middle unit there is your fire truck and those sorts of things. And then we have the technology available for your fire stations as a drop seal tile, that sort of stuff. In addition to the VOC, it destroys biologic airborne and virus, airborne and hard surface. So the units themselves have a 60-minute timer. When you turn your vehicle off, the unit runs for 60 minutes, effectively sanitizing the interior of your vehicle. So it's a great little product there. Next thing on your decon journey is you get back to the station, shower within the hour. NC State's proven that charcoal formulated soaps do a much better job of pulling the nasty of the fire off of you, out of you, and getting it out of your system than a moisturizer base that wants to push stuff down into your skin and those sorts of things. And then lastly, part owner at Toxic Suppression, his dad started an ISP washing turnout gear and that sort of stuff for the oil refineries about 35 years ago, long before the structural side started washing turnout gear. We have extractors, we have dryers, detergents, sanitizers, everything that you need to clean your gear, all your soft goods, all that sort of thing. Our kind of take on clean cab isn't so much as getting dressed at the scene of the fire, but it's a lot more in the vein of do everything you need to do as soon as you walk out of the fire. Start cleaning yourself, clean your breathing air, clean yourself when you get back to the station, clean all your gear, all that sort of stuff. So the next time that you make a fire, your truck's clean, you're clean, your equipment's clean, everything's good and nice and clean again. So again, always going to recommend escorting that tow. I find this picture kind of funny. It looks like Mater to me towing around the Cybertruck, and just get a kick out of that. In the vein of talking about escort to tow, this is one of my favorite actual slides of the entire presentation. To me, it brings a lot of everything kind of back full circle. And I like to explain this to people and saying there's generally for the past 3, 4, 5 years, whatever it's been, two things happened when a fire department dispatched and got on scene on an electric vehicle. They started flowing water and either had one or two things happened. Either they didn't get a breach in the battery pack. In that scenario, a lot of those were that 4, 5, 6 hours on scene, 20, 30,000 gallons of water, that sort of thing where they just kept flowing resources at it. That slowed the propagation fire. That's why it extended the burn time through the battery pack. Or they got on scene, started flowing water, had a breach in the battery pack, stopped the propagation fire, still had a bunch of those live charge cells in there, waited whatever it was, an hour, 2 hours, no heat signature, and then that's when they were loading up on the rollback or the tow truck and then sending it on its way. So that's kind of where this picks up, and to me it kind of brings a lot of this again full circle in that the use of this equipment, all these things, what we're proposing has already been used quite a bit for the last 4 or 5 years. We're just a different order of operations to kind of get to that point. So this illustration down here on the bottom was from Hurricane Ian. It was a Tesla, saltwater inundated, had a fire. Fire department went and put it out. They had a breach in the battery pack, obviously, stopped the propagation fire, waited an hour, 2 hours, whatever it was. Tow department came in. Luckily, this tow operator was a savvy guy, so he brought in the wheel lift truck with the wheel dolly versus the flatbed. Within 3 hours of having possession of it, it was back on fire. He pushed it out in the drive, or back out in the street, dropped it, saved his tow truck. Fire department came back in, dealt with it, knocked it out, ended up pushing it over in this kind of little pool of water here on the side of the road. Case in point being that all this equipment, towing it around, all that sort of stuff's already been done. You can see it right here. This just kind of methodology of how to do it, when to do it is a little bit different. And one of the other things to kind of point out with this slide is that in the early days, there was a lot of attention given to using rollbacks or immobilizing the wheels so that when you're towing an electric vehicle, you're not towing the wheels, which could be sending charge back to the batteries and igniting them, charging them, that sort of stuff, creating issues. But what they've realized is that when you get the car on there and it reignites going down the road due to the stop of the propagation fire and not all the cells being burnt out, that we're losing the rollbacks, and that it's a better idea to use the wheel dolly method so that you can just drop the car and you don't lose the actual truck itself. It's a little bit of a joke. Educate your law enforcement and tow operators. They're on scene, kind of what's going on with it. Tow yards recommending those isolation zones, that 50-foot parameter, heat and thermal imaging checks if capable, and then maybe potentials of suppression. Maybe the blanket stays with the EV and they have it there in case they have some issues. This would be the normal question portion of the presentation. Again, you kind of get a sense of this, what most people's concern, where you got the electric vehicle in a parking dead, it goes ahead and ignites. We'll go ahead and get in there, make the seat of the fire, get that knocked down with our hand line, deploy the blanket, the hand line, the nozzle over the top, go ahead and let that sit there and do its thing. If we get to the point that we can go ahead and move it out and get to a spot that we can open it up and let it burn through, that's great. If we got to continue in this deployment pattern of leaving it in place, letting the nozzle, the blanket, we got plenty of water, we protect our exposures, that's all fantastic as well. So a lot of great ways to deploy the products there. Again, lastly, thank you all very much for sitting through the presentation. Again, my name is Mark Lawson with Toxic Suppression. I do head up our lithium-ion battery fire suppression division. You can reach me at 770-328-1782, 770-328-1782, and my email is mlawson, MLAWSON, at toxicsuppression.com, mlawson, MLAWSON, at toxicsuppression.com. Thank you again. Have a great day.